Alrighty, here we go. This is section 11.3, the first video that you will have to watch for the second week of e-learning. So in 11.3, we're going to talk about inscribed angles. So let's go through a little bit of vocabulary here. An inscribed angle is an angle whose vertex is on the circle. Okay, so if I were to draw, I'll do red here, there's a vertex, and I draw an angle something like this. Okay, that would be an inscribed angle. Okay, the intercepted arc on the next one is the arc formed by the chords of the inscribed angle. So this right here is the arc formed by those two chords, so that is our intercepted arc. An inscribed polygon is a polygon who has all of their vertices. So if I went and did a triangle, you can do a quadrilateral, you can do whatever you want. That would be an example of an inscribed polygon. A circumscribed circle is the actual circle itself containing all the vertices of the polygon. Okay, so the polygon is inscribed, and then the circumscribed circle is the part that the polygon is inside. Okay, so let's go over a couple of theorems here. The measure of an inscribed angle, it says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Okay, so the measure of angle ADB is equal to 1/2 times the measure of arc AB. Okay, arc AB being from right here to right here. Okay, so there's a relationship where it's half of it, or you can go the other way where it's double. So that angle is half of the arc. Okay, so let's take a look at an example here. The measure of angle S. So if I look at angle S, this is the angle that I'm looking at right here. Based on our last theorem here, we are going to just take 1/2 times 60, which is going to give me 30 degrees. Okay. We want to find on the next one, measure of arc, what is it, RQ? Yep, so from right here to right here. Now we run into an issue here because that is not opposite an angle that I can deal with, but if we get a little creative here, opposite this 37 right here would be a 74. Okay, I'm going to scribble that in red, because it's twice whatever the inscribed angle is. Now, if we look at that entire piece, the green plus the red here, that's got to add up to 180 because we have a diameter there. So in order to find RQ, I could just go 180 minus 74. It's going to give me 106 degrees. Okay, so we just had to fill in a little bit of extra information there. So let's try a couple more here. It says find the measure of arc HJ. What do you notice about angle HGJ and HFJ? Okay, let's not get too far ahead here. Let's find HJ. So arc HJ, I'm going to highlight right here. Arc HJ looks like it is opposite this angle right here of 39. So I can say that the measure of arc HJ is equal to 78 degrees. It's just 2 times 39. Okay, and then it says the measure of angle HGJ. So I'm going to erase that, and I'm going to fill in that 78 right there. Measure of angle HGJ. So that is this angle right here that I'm looking at, HG to J. And that is an inscribed angle, with that being this 78 degrees being its intercepted arc. So this one is also going to be 39 degrees. Okay, so what do we notice about HGJ and HFJ? HFJ being this one. Well, they're congruent. Okay, and that leads us into our next theorem, 10.8. Because if you look at both of those angles, I'm going to erase this so it's not quite so messy. Both of those inscribed angles intersect the same arc. Okay, so theorem 10.8. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So on this one, angle ADB is congruent to angle ACB because both of them intersect arc AB. Okay, so this one is just asking us to name two pairs of congruent angles. Okay, so what I'm going to do is take a look here. We could do what? Angle PSQ is congruent to, I could go, so PSQ, I could go QRP. Okay, so PSQ and QRP, notice that they are both intercepting the same arc, so those ones would be congruent. We could do a couple of different ones. I could go angle, I forgot my angle symbol there, angle SQR and angle SPR. Does that work? SPR and SQR. Yep, so there we have it. You could name a couple more, but just as to do 2 pairs there. Okay, so you guys, I would like you to try and pause this, try and do these next couple on your own. These ones are actually pretty straightforward. Okay, when you have them done, unpause it and see if you guys got what I get. So this one, GHJ is this angle right here. It's half of that intercepted arc, so 50 degrees. Measure of arc CD, so this arc right here has got to be double, so that's going to be 80 degrees. Measure of angle RTS, so RTS is what I want right here. Notice that in green, the arc intercepted by that angle right there, that's going to tell me that this is 62, which then in turn means that this is half of it. That's back to our theorem where if they intercept the same arc, then the angles are congruent. So that one would be 31 degrees. Okay. So then theorem 10.9 says if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Okay. Conversely, if one side of an inscribed triangle is the diameter of a circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So in other words, what this is saying is if the measure of angle ABC is equal to 90 degrees here, so I'm going to put a little right angle symbol in there. That is true if and only if the hypotenuse is a diameter of the circle, meaning it is a chord that goes through the center of the circle. Okay, we're going to use that one here in a couple of slides. Theorem 10.10 says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So remember, supplementary means that if you add them up, it gets you to 180. Okay, so this angle and this angle would have to be supplementary. Do it in a different color here, and then the 2 black stars. Opposite angles would have to be supplementary, adding up to 180. So let's give one of these a try. To save time, I'm only going to do one of them, and I'll just put the answers up if you guys want to check. So over here, this one should be x is equal to 15, y is equal to 30. So you guys can try those on your own. I'm going to go over the first one here. So if I look here, opposite angles I know have to be supplementary. So that would mean that 100 plus y has to be equal to 180. So that's going to tell me that y is equal to 80 degrees. Okay, the other two, that would have to be, what, 88 plus x is equal to 180. So that would tell me that x is equal to 92 degrees. Okay, same idea over on this one. You would just take 3y and 3y add up to 180. 8x and 4x add up to 180 and solve. Okay, I don't know that we need to spend a whole lot of time on that one. Number 4 is saying that a right triangle is inscribed in a circle. The radius of the circle is 5.6 centimeters. What is the length of the hypotenuse of the right triangle? So this is taking us back to the theorem about our right triangles, where we said if you have a right triangle, that angle is 90 degrees if and only if the hypotenuse is a diameter of the circle. Okay, so if I tell you the radius is 5.6, what is the length of the hypotenuse? You just got to double it. Okay, so we would have to take 5.6 times 2. So what? 11.2. Okay. Number 5, find the values of A and B. So let's take a look here. I've got a quadrilateral here, so I know that this one and this one together have to get you to 180 degrees. So I could say that 5A plus 90 is equal to 180. So 5A is equal to 90. A would be equal to 18 degrees. Okay, the 4b here, I could say 4b plus 96 is equal to 180. Careful, that's a b. So that's going to give me 4b is equal to what, 84. Divide by 4, and we would get b is equal to 21 degrees. Okay, there we have it. Your homework, page 676,